Okay, let's start. Okay, let's start the second round of our conference. And I would like to invite my friend Ivan Ivanchenko, who lives in Belgrade, Serbia. So, warmly welcome our next speaker.
Hello. Hello, RubyWine. Yes. Thank you. So, yeah, my name is Ivan Ivanchenko, and it's actually enjoying to pronounce it like this and not like Ivan Ivanchenko, like I have to do it on other conferences. And a bit about me, like. Speaking of how I use Ruby, I do it mostly like any freelancer do. I don't have a luxury to work on one single project for a long time. I switch from one project to another pretty quickly, and therefore I was able to learn from a lot of different decisions, from a lot of different solutions. And I love this, and what I do a lot is exploring architectures. Also, I'm writing a book where I describe the way I use Rails so that it don't hurt you. And I also teach at one online Russian-speaking school called Good Programmer. And if you have a friend who always wanted to become a programmer, but for some reason they postponed it, you simply can send them to us, and in 6 months you will get a junior Rails developer back. And also I'm a big fan of GitLab. I worked there for 1 year as a developer advocate, and I still have some stickers, so if you really want them, you can grab me after the talk and I will give you some. And during my work at GitLab, I used to travel a lot, and today I am also on a Ruby trip. I decided to attend, to visit 4 different Ruby conferences in 40 days, and this is my Ruby stop number 3. And as you can imagine, when you travel so much, like a lot of things can go wrong. For example, one of the airlines where I bought the ticket from simply went bankrupt, so I have to buy another ticket 3 times more expensive. And another airline simply canceled their flight, so I was, and the flight was from Verona to Chisinau. So I had literally to run to airport and to get to another flight. And thanks to organizers, they met me during the night and provided a place to stay, so I'm finally here. Because the replacement ticket they offered me was something like on Saturday, 8 in the evening, so I would even miss after party. And another thing which is kind of not very wrong, but a bit unexpected, this is the view from my so-called hotel room. Actually, I loved it because like the house and it looks and feels and smells like one of the house of my grandparents in my childhood. Also, it was a very silent place, so I was finally able to rehearse my talk. So hopefully it went okay. And 2 more things before we start. I always forgot to do this, but now I want to do it. I want to do the selfie with you, so that I will have at least one selfie with you. And thank you. And if you visit any of those conferences, we might meet there and come and say hi, and we'll have a discussion. And I hope you enjoy RubyWine as much as I enjoy my stay in Moldova so far. And let's get started. So, what is my talk about? The idea is to provide you a brief overview, to talk about our job as a Rails developers, as Ruby developers, as web application developers, from different perspectives. And hopefully it will help you to highlight some areas and to make you better developers. And here's the initial list of aspects I wanted to go through. And yeah, initially there were like 12 items. Right now, when I applied to the talk, to the conference, there were 6 items. And then when I finally started working on my presentation, I decided that I have to reduce the number of these aspects to 3, so that my talk will be actually at least somewhat practical and useful. And I see a lot of young faces here, and that gives me hope that the talk is going to be useful. It's not really hard, but let's start with the system thinking. And the system thinking is actually a really complex thing. And if you speak Russian, then you can follow the link and learn more about system thinking. There is a guy called Anatoly Levinchuk, and he is probably the most famous person who cares about system thinking in Russian. And this is his online course, and it's pretty good. In English, you can take a look at the standard, and there are all the definitions, but we are going to talk about 2 simple concepts from the system thinking and consider it a warm-up. So let's talk about roles. And yeah, you remember this picture? Let's zoom it and enhance. And you see there's a dog, and there's a dog house. And almost anyone can build a dog house. And almost anyone can build a small hut. And therefore we can call this person a builder. And experienced builder can build a small house, because they already built few huts and small houses, so building another house is not a problem. But when it comes to building something bigger, really big house for multiple families, then it suddenly, then skills of our builders is not enough, because we have to care about electricity, we have to care about plumbing, about gas, ventilation, heating, about how we're going to deliver people to our apartments, and so on and so on and so on. And what is happening in real life? It's a conceptual compression, but I guess what happens is that some person who is aware of all those aspects delivers like a lot of different documents, diagrams, schemas, where they describe all these aspects. Then a really smart person somehow merges all these aspects in their head, and then produces the final document where, with a description how exactly this building should be built exactly on this area. Well, in our case, we have something like this. The same person who built a hut then is expected to turn this hut into a small house and then to turn it into a bigger house. And for us, what happens is something more like this. Like, the person who built the hut uses the same principles to build a bigger house, and then uses the same principles to build a really big house. And it's not surprising that such systems are causing a lot of efforts and pain when you have to support them. So the key idea here is that if you are going to build a really big system, then skills of a developer is not enough, then you should start developing architect skills. And it's not necessarily something like was shown on the DDD talk, because this is this architecture was done by a very profound architect. You should really introduce some of the aspects, and we'll talk about a few of them, and I hope they will be useful. So, and I was questioned what could be the criteria when you should start thinking about architecture. And my opinion is that you should start thinking about it from the day one. But also, another question is, when will you start feeling when things will go wrong? And I think, it's just my guess, but I think somewhere at the level of 75 plus models, you will really feel the lack of architecture. Okay, another idea from system thinking is lifecycle. And it is useful to understand that our project have life cycles, and during the inception stage, architecture actually brings no value to you. And this is shown on this picture by Martin Fowler. Actually, this red line shows it's a desired state. It means that over time we are able to deliver the same amount of new features we were able to deliver before. But what usually happens is this blue line, where speed of delivery decreases because of lack of architecture. But also you can see that in this part, no, you can't see. This part on the bottom, there is no reason to invest in the architecture. Also, it means that we can draw these stages like this, and they can be of a different length. And for example, for GitLab, their situation can look like this. They had a short inception phase, then they had a huge growth stage, and I think right now there's they're on iteration stage. This is a not very desired situation. This is like a long inception phase where you've been working on a project maybe silently for 2 years without releases. Then you finally release it, but nobody gets the idea. You probably get several clients and you have to support them, but you have no huge success. And there is another situation, and I find this situation very relevant to us to Rails community, because startups do love Rails because we are able to deliver features quickly on the first 2 stages, and they do hire us. But what really happens is that 9 out of 10 startups die before going to the next stages. And for us, it means we are not able to learn from our decisions, that we are going from project to project, and we are completely sure that we did everything wrong, did everything correctly, and we teach others to do it the same way, but we are we don't have real experience of scaling our decisions, to building a really big house out of our decisions. So just next time when you join the project, think about what stage, what this project is, and what stages you will be able to participate in. All right, the next idea. And we are about to start getting practical. And I have a question for the audience. Who of you, please raise your hands, those of you who know what is state machine. And please keep your hands those who use it on a daily basis and who believes that it's a really important concept. Okay, fewer people. So yeah, my talk is going to be useful. All right, so let me demonstrate the idea of state first. Let's say we all have user model, and user can be in different states. Invited, registered, banned, promoted, expired, maybe deleted. And also we have other models, and they also can be in different states. Probably invoices can be attached to tasks for some reason, and tasks can be assigned to users. And it means, and here we get a combined effect. Like the more combinations we get, the more complicated our system becomes. But the trick is that, like, the natural way to implement states for us as developers, like when we just learning how to do stuff, is this. We use flags, and we love flags. And this is the code I've written several years ago. It all started with one simple condition, but then customer asked me to add more logic, and I found myself in a situation where I don't understand where should I put my code in. So if you remove HTML, it will look a bit simpler, but still, it was really hard for me to understand where everything should go. And another indicator is situation like this. If you find yourself writing conditions like this, you're in trouble, because every time you will go through this code, you will have to parse the whole thing. And what it means is that you try to identify the state somehow, but the way you do it is very not very good. You could hide it behind a method and name it somehow, but you will still have the same problem. Like every time you will have to introduce changes into your system, you will have to go through the whole thing. And it's getting even worse, because every flag in the model you add actually doubles the number of states. So when you only have a flag, like trial ended, for example, you have 2 states, trial ended and not ended. But with every next flag, you double the number of states, and it means that for 4 flags in one model, you have a possibility of 16 states. And as you remember, if something can go wrong, it will go wrong. And it means if you leave the theoretical possibility in your system to switch to the incorrect state, it somehow can happen. Like someone will import not validated data, or because of some bug in your system, you will get incorrect data, and your system will not be able to process this data correctly. And if you have like conditions like this, good luck with debugging it. I know it's here. So flags can be hidden. It's actually on my slide. And what I mean is that sometimes we use dates, we use ranges or associations or status fields as flags. For example, if some association is missing, then it means that our user is in this state. And it makes things even more complicated. But there is a natural solution for this, and it sounds like state machines. And the key idea, one of the key ideas, is that almost everything we are doing as a programmers can be represented as state machines. And this is an example of state machine. And this is what happens when you're trying to call a friend. And the idea of state machine is simple. You have a number of states, and you have a number of transitions between them. And that's it. And there is another state machine, like when you put in your MasterCard into ATM, here's the state machine, and like after a third try, it hits your card, and that's it. And state machines can be complex. This is a state machine of a Docker command line utility, but still it's a state machine that can be described with this idea. Luckily, we have two good gems for that, and I used the second one, but I think they're kind of have the similar functionality. And in the code, it looks like this. You define, in your model, you define the list of states and a list of events with transitions from one state to another. What it gives you, it basically generates you a list of methods, and you also can generate scopes out of it automatically. And in your code, it gets easier to read, so it's always explicit. in what state you are, and also you can use state name as a name of the partial and make your view even more simpler. So, if there would be only one thing you will take from this talk, please just use state machines. Start using them. That's the only thing I really want you to learn from this talk. But there's another layer on top of it, because in Rails, models are backed by active record. Models can be in two states, like we can call them technical states. It can be persistent or not. And it means that if we have 16 states with flags and 2 states like safe, non-safe, now we have 32 states. You see, right? So what to do here? Try to write the code which doesn't rely on the technical state of your model. Your methods should treat models the same way, no matter if they are persistent or not. It might be hard at the beginning, but it's really important. So the idea here, if we're going to summarize it, it will sound like this. You should control the number of degrees of freedom in your application. And the number of degrees of freedom is the combined number of states of your models. All right. And the last thing I wanted to talk about, it sounds like entry point pressure. And this is, don't try to Google it because I actually invented it. And what are entry points in our Rails applications? Entry points are actions in our controllers. And what I mean by pressure is something like this. So if in the controller you have like huge list of default fillers, and it's really hard to understand where each piece of the code gets executed. And because of the fact that you're trying to handle too many business operations and different contexts in the same action, you might get a code like this. This is a single action. Yeah. So I call it a very high pressure. You can use this metaphor of high pressure on a single action, and the solution is to decompress it, to identify, this is the picture that should demonstrate the idea of pressure somehow, and I think it goes from several false assumptions. The first one is that I know that some juniors still think that REST means that we should have one model and one controller. It's not the case. And also, there is a default way to handle different formats in Rails. It's respond to. And because of this, our code in controllers gets more complicated. So what I suggest is to identify separate chunks and to move them to separate controllers. And the first principle, well, let me first demonstrate the problem with respond to. On a small scale, it doesn't really look scary, but on a larger scale, it gets scarier. So enjoy it. What we see here is that for every case, we have a different subsets of data. We have different ways to generate results, and probably all these results will be used in a different way, but we still put this in the same controller. And also, the list of actions is also different. Like you will not have an update action for RSS feed. So the solution is to create separate REST representations. It means like separate controllers. And one of the approaches is to use top-level namespaces by the format. So if you have to serve JSON, you can create a namespace called API. If you have to serve PDF, you can create a top-level namespace called reports, for example, and for the regular controllers, you can put them into web. And another approach is to use the idea of bounded context. And by bounded context, well, you already heard, but let's repeat. Maybe it's a confusing word, but it's simply that you might have a moderation section, you might have a marketing part of your business, you might have sales, support, and those can be treated like sub-applications, something like this. And you also create namespaces for them, and you get a hierarchical structure for your controllers, and this actually reduces entry point pressure, and yeah, this is the principle I would love you to use as well. And I'd love to know how much time do I have.
11 more minutes.
Oh, that's perfect. Then we can talk about another concept. Remember the idea of lifecycle? From the beginning, let's use it for our life cycle as a Rails developers. I wrote this picture, I invented this picture a year ago when I was preparing to RubyC conference in Kiev, and I used it to describe my trajectory as a Rails developer, as a Ruby developer, and then I figured out that it actually describes like any Rails developer. So the detailed picture is, you can follow this link. I won't show you the detailed picture right now, but yeah, you can't actually see anything. But the idea is following. On the first stage at the bottom, we all happy with Rails. We fell in love with it. We think that it's something really amazing. And then, as the project grows and we started to work on more complicated problems, then we start getting problems with Rails. We switch to the second stage of Rails critics, and we start maybe not hating Rails, but seeing some difficulties, and we start looking for solutions. We learn about design patterns, solid, and so on and so on. But the trouble here is that sometimes these solutions, we are able to tackle complexity, but we still don't get the same level of happiness we were able to get on the first stage. And because of this, a lot of people switch to the third stage, where they decide to leave Rails community completely, whether they decide to switch to another technology, Clojure, Go, Elixir, Rust, Go, or I don't know, PHP, just kidding. Or it's a different paradigm. We will go like completely event sourcing, or we'll go serverless or microservices. We are tired of the problems we have with Rails or like Hanami or something like this. We are going to have to deal with completely new landscape of problems. So, the trick is that there is a fourth stage, and it's really hard to get there. The only way I know is to learn from all those different languages, to learn from all those different paradigms, and then bring these concepts and these ideas back into Rails. And it's actually doable. I was able to learn this approach from one person, and I'm trying hard, trying to write it down, trying to find an easy way to transfer this knowledge to other people. And one of the attempts is this list. I tried to formulate a list of Painless Rails principles, and you can use it as a checklist. You can check yourself whether the way you use Rails, the way you write web applications, complies to those principles. If it is, then probably when the code base grows, you won't have serious problems. If it's not, then you might get problems. And you still can learn these things and these concepts by yourself. This is the list of books you might want to get through. The problem is that not a single one has a mention of Ruby or Rails, so it's just pure ideas, or maybe even other languages. So, as I said, you have to get the ideas and then transfer them to the way you work first. If you want to learn more, you can sign up here. This is a mini email course, which I've extracted from the book I'm writing, and that's it. Thank you. If you have any question, I'll be happy to answer you.
Hi. So we saw this design stamina hypothesis chart. So my question is, what is good design? Because we saw like there is no design and good design. So what is good design? And are there any numbers? Because as far as I know, that chart is a conjecture. There's no objective proof to it, and there are no numbers whatsoever. So if you apply any scale to this chart, it can drastically change. So yeah, what is good design and what are the numbers?
Yeah, it's a hypothesis. You're right. And as for what is good design, I think there should be a separate conference for that. Because what I tried to do in my talk, I wanted to show several concepts which will lead you to a good design. And if you really want to modify the way you write, you develop applications, and you want them to have a good design, you should be aware of somewhat like 10 or maybe 15 concepts. That's the idea.
Yeah, that still kind of doesn't answer my question, because what if I don't what if I don't go towards good design? I mean, so we want to start on the premise what a good design is, to kind of understand if I want to go this way. So, is good design like using state machines and low density entry points?
It is one of these are two aspects you should comply here. You should care about. Otherwise, you're this is your situation. But there are more to it. Yeah, I simply have no time to talk about right now. I can answer you later.
Yeah. Thank you.
Hi, thank you for the presentation. Could you turn back one slide, please? No,
This one?
This one, yes. Isn't the picture on the right this monstrous monolith, which a big part of our industry is running from? This is the first question. And the second, the practical one, which state machine gem would you recommend? Because there are 4 or 5, and one of them difficult to understand.
Okay.
What should be used.
Thank you. So as for the gems, I know 2 of them. I showed them. One is AASM, Access State Machine. Another one is State Machines. I used the second one, but I believe they are kind of similar. They have similar functionality. So the trick is that they provide actually too much functionality. They provide something like callbacks. Please don't use it. Like everything like you saw. Let me find it. I show you this is everything you need for your state machines. Yeah, that's it. Yeah. Sometimes you will have to put some conditional validations inside the state, but usually it should be really simple. because it can get messy too if you like start using all the features. But yeah, that's it. Okay.
Well, basically, you don't need a gem at all, because you can just create a hash with your transition table, and you might send the key with the current value, and you will receive the value with your possible transitions. So you don't need a gem.
I thought you tried to remove me from stage. Okay, the second question was about monolith, and I think that the reason why we are trying to escape monoliths is that we don't. We are trying to introduce boundaries so that we don't. So that we have like a number of separate huts like this, so that it won't turn into this like situation, right? So, and the answer is, if you learn about good design, your monolith application will be fine. And it's actually, how to say, I highly recommend to go through this stage before you start switching to microservices or something like this. As I said, there you will have a completely new landscape of problems. And if you don't know how to deal with the problems of monoliths, it will be even harder for you. It might be even harder for you. Thank you.
I also have a question. It was a great speech. Actually, have you had a situation when some state machine brings you headache? I mean, when it was really hard to debug something because all logic was hid behind callbacks of state machine, and maybe you have some advice how to get rid of it.
Thank you for your question. As I said, try not to use all the features provided by gems, like try not to use callbacks inside state machines. Use it as a way to define rules of your model. Like you always have to think what idea you're implementing using some solutions. Like behind every gem, behind every decision to use like some certain building block, there should be an idea, and specific solution doesn't always follow your idea, like the idea you have behind, and this is up to you. This is like another part of skill of good design. But from my perspective, yeah, it can get messy because you have to, sometimes you have to remodel the whole thing, and you have to rename maybe half of your events, and then it can get harder. And also, like, you might be in a situation where one model can have multiple state machines, and it's also important not to mix them into one. That's like from my experience, what I know. Thank you.
Thank you, Ivan. Let's make a quick picture together.
Thank you.